Assalamualaikum and a very good day I bet to all. My name is Nurul Nabila Izzaty Binti Ahmad Zamri. I am a fourth year student of Faculty of Electrical and Electronic Engineering Technology of Universiti Teknikal Malaysia, Melaka. Today, I would like to present my Bachelor Degree Project 1 entitled of Development of Intelligent Switching System integrated with PV solar system. First and foremost, I would like to thank and praise both of the assigned panel that are going to evaluate me at this very moment, which is IR Dr. Faris and Technologist Dr. Sharil. Without further ado, I will start my presentation with an introduction about my project. Introduction. The primary purpose of this project is the design and development of an intelligent switching system integrated with PV solar system and Arduino for a small scale applications. In my project, the small application are focusing on the lecturer's cubicle or staff room in the faculty itself. The development of intelligent switching system integrated with PV solar system for this study is first, the radiation of sun for the solar. Second, the solar energy itself. Thirdly, the type of solar panel that is going to be used in my project. Next, the solar charger controller, which I already selected is the Pulse Width Modulation PWM Solar Charger Controller. Next is the Arduino Uno as the microcontroller interfacing with a LCD type of display to display some sort of voltage, current and power. Next is the type of sensor usage to make it an intelligent system, and lastly, the type of solar rechargeable battery that will be used in this project. So, the problem statement in my projects are, firstly, we can see that the high electricity demands monthly in our campus are causing high electricity bills per month. We can see that the needs from the laboratories, from the staff office, lecturer cubicles, and even the administration building itself. We can say that every building in our campus is equipped with an air conditioning system. The laboratory itself even have higher demand of electricity, and the lecturer cubicle itself donated some unnecessary usage. What is the unnecessary usage that I mentioned before? The unnecessary usage is we can see through sometimes when the lecturers are in rush leaving their cubicles, whether it is to rush to go to class or to the administration office, they tend to forget to switch off the lights and the wall outlet socket that are connected to their electronic device. And we can see that the air conditioning system in our faculty in our campus needs to be run from 8 a.m. until 5 p.m. in the evening every single working day. From Monday, Tuesday, Wednesday, Thursday, and even Friday. So we can see that there are times that the electricity is not even needed, such as when there is no one in that particular room, and sometimes student tends to forget to switch off the lamp. Objective. So there are only two objectives that I need to achieve in my projects. First is to design and develop intelligent switching system integrated with PV, solar, and Arduino. The second one is to analyze the functionality of intelligent switching system integrated with PV, solar, and Arduino. So for the scope and limitation, the scope that I'm focusing on my project is the standard measurement of the lecturer or staff cubicle in the faculty itself. We can see this at the administration building, the pigeonhole area. The staff cubicle at there, that is my benchmark for the standard staff cubicle measurement. And the limitation of my projects there are two. Firstly is the lighting switch, and secondly is the wall outlet socket. So the limitations first are one lighting switch and two of the wall outlet socket. So these two will be the limitation of my projects. So here's the major component that I used in my project. Firstly is the monocrystalline photovoltaic panel. Secondly is the Arduino Uno interface with LCD. Thirdly is a pulse width modulation solar charger controller. It's a PWM solar charger controller. The fourth one is the lithium-ion solar rechargeable battery. As we know, solar rechargeable battery usually use two types of battery. One is the lead-acid battery, and the second one is the lithium-ion solar battery. The fifth component that I am using in my projects are an inverter. This inverter the fifth component that I use in my project are inverter. The inverter is to convert the DC supply voltage from the lithium-ion battery to an AC supply before it go to the distribution box. And lastly, the major component that I use in my project is of course the sensor, which I already choose is a motion sensor. To be specific, is a passive infrared motion sensor, PIR motion sensor, which offered both motion and infrared wave sensor. So here is the flow of my project. Firstly, I set up the two objectives that stated before. Secondly, I identify the problem statement. The problem I see is the problem that I can take and see is from my surrounding, which is the unnecessary spending on the electrical. Next is to gather the information. To gather the information, I search the online articles that have been done before this, from the websites, from the online books, PDF that I can get, and the literature review. I got 4 different parts, which is for the solar panel, for the microcontroller, for the solar charger controller, the motion sensor, and lastly for the battery itself. So after that, I get to design the system. I get to design the system that I wanted, the intelligent system. So the intelligent system which needed a solar panel, a microcontroller, a solar charger controller, and a battery to restore the energy from the solar, an inverter to convert the DC power that we get from the battery to an AC power before we can get it supplied to the distribution box, and the sensor that will make my project to be an intelligent project. So next is the electrical load that I have choose to mimic the usage at the lecturer's cubicle or the lecturer's office itself. So firstly, I choose the light switch that is using a LED bulb which consume about 6 watt. I choose the LED light bulb as the LED consume less current but they have greater lux. So we can next the next electrical load is a 2-wall outlet socket which each of it will be used as a phone charger or a power bank that consume about 10 watts, and a humidifier which also consume about 10 watts respectively. So the value of the power usage from each load are very important. This is because we need to know the load consumed to choose the suitable design for the solar panel, the lithium-ion battery, and also the PWM solar charger controller. So next, why intelligent? I called my system as an intelligent system because of the sensor I choose to help encounter the problem stated above. We need to reduce the electricity usage by cut off the unnecessary waste of usage, such as forgot to switch off the outlet socket and switch off the light when not in use. So, therefore, passive infrared motion sensor (PIR sensor) will help solve the problem. Why is it so? PIR motion sensor is when someone enters the sensing range. The sensing range in my context is the lecturer cubicle. The PIR motion sensor, like the PIR motion sensor light will automatically receive the infrared wave emitted by the human body, which is our body heat. And the infrared wave will be sensed, and then the light will on. When the human body leaves, or simple we can say that when there is no human body heat, the infrared wave are not received. Therefore, the lights will automatically turn off. Okay? So, as long as the human body does not leave the sensing area, the cubicle, the office, the sensor switch will continue to be turned on. After the person leaves, the delay will automatically turn off. So, it usually takes about 30 seconds depending on the delay will automatically turn off. The delay, usually the delay will take something about 30 seconds. So when people come again, when people re-enter the room, the office, the cubicle, the lights will turn on. And when the light is turned off, automatically, the lights will automatically turn off when there is no motion, which I can say that is quite humanized and energy saving, right? So, as the conclusion of my project, the design and development of the intelligent switching system integrated with the PV solar system and the Arduino are on the right track. Firstly, the intelligent system comes with the sensor that implements human body heat or human infrared wave, and the motion sensor called passive infrared motion sensor. Next, the photovoltaic solar usage is intended to reduce the usage of the primary electrical sources of the lecturer cubicle itself. And besides that, solar energy is one type of the renewable energy that is suitable for an academic institution to own. This is because the solar energy it's quite pricey. It's quite costly for us to develop it in the first place. But we have to think further. The solar energy does not need constant maintenance. I mean, like if we bought the suitable design, there is enough to equip our power usage, then we can already calculate the measurement for us to get to the next maintenance, and it can save some money from the bills that the university need to pay to the TNB monthly. Next is the integration with an Arduino interface with a liquid crystal display and LCD between the solar panel and the solar charger controller can monitor the input and output of the solar charger controller from the solar panel itself. This way of installation helps a lot when it comes to maintenance, when it comes to the part where we need to maintain the part of the solar panel efficiency. So we need to know that a solar panel it has its own efficiency rate. So in order to achieve the saving of the energy that we need to maintain the efficiency of the solar panel. But By doing that, we need to install a system that needs to make us easier to get to know what is wrong with our solar panel. So we can use the Arduino. We can make a simple coding for us to display the power, the current, the voltage from the solar panel to the battery. We can put the Arduino interface with a LCD display in between the solar panels itself, the PWM solar charger controller before it entering the battery. So I think that's all from me. Thank you.